Now I'd like to introduce you to the RS232 standard protocol. RS232 stands for the Recommended Standard Number 232, and it's a fairly old standard. It goes all the way back to the dawn of computing, and it defines a serial protocol that's really commonly used because it's very simple. You can find it in GPS units, you can find it in ultrasonic sensors, you can find it in fingerprint sensors, you can find it in radio links. It's a general purpose protocol that's often built into devices that need to communicate between microprocessors. So what all of these devices have in common is that there is some local processing that's occurring and information has to be exchanged, and they can communicate back and forth using this RS232 standard. This is not the only standard, and it just happens to be one of the oldest, one of the most common on microcontrollers. So we can find it in lots of places. The RS232 standard, it's an active low standard, which means that a 1 bit, a bit 1 is represented using a low voltage, and a bit 0 is represented using a high voltage. And the reason why this is, designers of this protocol wanted it to be clear when a line was connected. So the idle state is high, or rather the connected state of all zeros is a high voltage. So they know that it's not just like a dead line or something like that. It's a high voltage. So they know that there's something on the other side. The system defines baud rate as bits per second in this case, and that helps us define how this works. So this is a asynchronous protocol. A clock is not a clock signal is not included, so we have to make sure that both ends of the communication link, the receiver and the transmitter, both agree on the same bits per second, or baud rate, so that they can time how long to wait before the next bit occurs. The frame idle is low voltage, or all ones. The start bit is a 0, so it brings the voltage high and then it goes low again. And there's usually 8 data bits, but there can be up to 9. So the protocol defines 8 or 9 bit frames, and the stop bit is represented as 1s forever, which again is a low voltage. The bit order is undefined. It could be least significant bit first or most significant bit first. That's entirely up to the transmitter and receiver. On our particular devices, it's most significant bit first, which is the most common format for these things. Here's an example of an RS232 frame. In this case, we have our idle starting out low, and you can see that what was missing from that protocol specification is the voltages, the specific voltages. So RS232, the protocol is not specific to a particular voltage. So it can be anywhere from 0 to 12 volts, or in this case, it's even, it looks like it's like -5 to 5 volts. So we can have all kinds of different ranges. That produces a lot of electrical difficulties, and that's why one of the devices we looked at earlier this semester was the Max 232 level shifter, because we can convert between any two levels of RS232 protocol using that device. So if we have a 5 volt device that needs to talk to this bipolar plus minus 5 volt, we can use that device to communicate between them. So it starts out idle, which is the low voltage state, or all ones. It sends a 0 start bit, and then each of these bits is sampled on these sample ranges here. So you can see that the time, both processors have to wait a fixed amount of time between the two bits, and this is the bit period. So for example, if we have a baud rate of 19.2 kilobits per second, 19.2 thousand bits per second, the time that it takes to transmit 1 bit is the inverse. You can think of this as a frequency. So it's bits per second. The time for the period for 1 bit is the inverse of that. So 1 over 19.2 thousand is 52.08 microseconds. So both of these devices, the transmitter and the receiver, have to have precise timing hardware that allows them to precisely measure out 52.08 microseconds. The advantage here is that if we both publish the same protocol, if we both say, I'm going to participate at 9600 bits per second, then any device that's able to handle 9600 bits per second will be able to listen and communicate with messages like with messages over 232 RS232 at that baud rate. So it's really easy to set this up, but we have to have very precise timing hardware on both ends.